All right, guys, let's take a look at a couple homework questions that were asked here from section 1.1. So 66, 67, 68, actually 69 and 70, all six of those problems use this same graph right here that your book called figure number 27. And in this graph, we just have this weird little piecewise linear function right here with a series of lines, segments connected here at a few points. And we're supposed to graph some variations on this graph. So one of the things I probably should have listed here that's kind of important is that this original graph is given to us right here as the original function y is equal to f of x. And with that in mind, then, we were asked to make some shifts on that graph here. So let's talk about what's going on. 66 is actually two questions. And the first one, they're asking you to graph f of the quantity x plus 2. So what I'm hoping we've noticed in this graph and over the last couple of years here is that anytime we have a 2 that is added inside the parentheses right here, that's basically taking the place of an h, everybody. And so when we have an h involved right there, that is always going to give us a horizontal shift. So adding 2 inside the parentheses is going to shift our graph 2 units to the left. So instead of starting right here at the origin at 0, 0, that thing is now going to move left to a negative 2, and it's going to begin at this spot right over here. Okay, so that's that graph. And in fact, what else is going to happen is that every single point on this graph, and we're just going to focus on the 4 significant points, but every single point on the graph also shifts 2 units to the left. So this point right here, which was at 2, 4, now moves to the left to 0, 4. This little minimum here, which was at 3, 2, is now going to move to 1, 2. And then the end point on the right here, which was at 4, 4, now moves to 2, 4. And if I connect those 4 blue dots, you'll notice we get the exact same shape we started with, but now it's been shifted 2 units to the left. Now moving on to the second part of this graph, what I've labeled in green right here, f of x, then close the quantity, and then a plus 2 at the end. So now instead of talking about an h, now we're talking about a k that's being added at the end. And what it does with a k value, any value that you had on your function, or I should say all values you had on the function, are now going to be shifted 2 units up. So again, looking at the original red graph, we started this thing at 0, 0, and then we're moving 2 units up from there. So this new green graph is now going to begin at the point 0, 2. And likewise, every other point on our graph is going to shift up 2 units. So I'm just kind of eyeballing this obviously here, and that's going to look something like that. So we'll connect those 4 green dots. All right, and that in green there is the graph of f of x, and then plus 2. So 3 different graphs all on that same one right there. The original in red, and 2 different variations there in blue and in green. And while we're on the subject, let's go ahead and talk about 67, which again is asking you to take the same original graph here and make a couple of different modifications to it. So the first one they asked for in problem number 67 was to take f of 2x compared then to the original function. Now, what this 2, that is a factor of x inside the parentheses, is probably most closely related to, in your minds, that you guys have seen in the past, would be when you guys were talking about a graph of a trig function, like y is equal to, I hit a button here again with my hand, sorry. Y is equal to the sine of x, which of course, at least I'm hoping anyway, we recall is a graph that looks something like this. And if we thought about a variation on that looked like y equals the sine of 2x, I'm wondering if you guys recall that or not. What that did in a trigonometric function is it played with the period, the amount of, I shouldn't say time right there, but really the amount of horizontal space it takes this thing to cover to complete one full cycle. And if you recall, I always felt this was a little bit counterintuitive. Putting a 2 there actually compresses the period now by a factor of 2. So the normal period of a sine wave was 2 pi. That's how much space it took to complete one full cycle. Now by putting a 2 there, we're going to compress that period down to just 1 pi. So what would happen on a sine wave? Here's where it starts, here's where it ends. Halfway through we have another intercept in the middle, and we have a peak here and a trough here, and that in blue, not very well drawn, Mr. Fontana, that in blue would be the sine of 2x. Its period gets compressed horizontally by a factor of 2. Now back to the issue at hand here in problem number 67, this certainly is not a sine wave, and it's certainly not a periodic function. But the point remains the same, that this original red graph took 4 units along the x-axis right here to do what it does, to complete one little zigzag. Again, I shouldn't say cycle or period here, but to do that. And now what we're going to have to do is just kind of think about a big wall right here moving back over to the left. I'm thinking of that trash compactor scene in the first Star Wars movie, Episode 4, everybody, where this thing is just going to push back to the left. So here's what happens. Notice back down here on the sine wave that both sine of x and sine of 2x started at the same point. That didn't change at all. Well, that same thing happens for us right here. The original red function started at 0, 0. Compressing that isn't going to change that point at all. That is still going to be 0. In fact, if you think about that, we knew, let me switch to red here for just a second, we knew that f of 0 was equal to 0. Okay, so letting x equal 0 right here is still going to get us, well, 2 times 0 is still 0, so that's still going to be f of 0, and it's still going to give us a y value of 0. So the starting point doesn't change at all, but the ending, in fact, every other point, now gets compressed by a factor of 2. So let's take a look at this point right here, which is currently at 2, 4. It moves half of the way back over here towards the y-axis, and that's now going to be at the point 1, 4. This endpoint right here, which is at 4, 4, moves halfway back to the y-axis and now moves to this point here, which is at 2, 4. And I guess if we wanted to get difficult here, this minimum was at 3, 2. It moves halfway back and would now be at 1.5, 2. And again, I don't think my spacing is great right here, but I wasn't really going for accuracy on this graph. It would look something like this. So the new horizontally compressed graph is going to look something like that. Okay, and that is the first part of 67. The next one is f of 1/2 x, and I'm guessing you guys could probably guess that putting a 1/2 in that spot right there is going to have the opposite effect and is actually going to stretch your graph out horizontally now by a factor of 2. The last one right there, I'm thinking you guys probably remember, the third part of 67 was y equals 2 times f of x. And if we recall here, to multiply any function by a factor of 2 out in front, that one is simply going to apply a vertical stretch by a factor of 2. So going back to the red graph here, the maximum value of the original red function was 4. In this function right here, that max is going to double, and it's going to go up to 8. So that graph, I guess I should have done this in a better color right here, that graph right there of 2 times f of x is going to follow the same horizontal spacing as the red one, but it's going to be twice as tall. So that one in green is probably going to look roughly something like that. Okay, everybody, hopefully that explains 66 and 67 just a little bit. I'll come back and talk about 68 in just a minute.